Multiplying polynomials. Okay, so yes, we have done this already, but these are the special cases, which is still just the same multiplying you already know. But if we can learn to recognize these special cases, then it'll really just make you a more efficient mathematician as we move on. So you have a warm-up at the bottom. Please take a minute to do this multiplication, either with distribution, rainbows, or a table, or however you choose to solve. Okay, so if we are reviewing just multiplying binomials and realize that is different than what you did in your warm-up was a binomial, so 2 terms, multiplied by a trinomial, 3 terms. This is just multiplying 2 binomials, so they both have 2 terms. When I multiply these, I'm just going to go ahead and do, let's say, maybe rainbows, which is the same thing as foiling, if you have decided you like foiling. So my 3x has to multiply by my x, so I'm going to have 3x squared because I'm adding these 1 exponents on my x's. My 3x also has to multiply by my 3. 3 times 3 is going to be 9. Okay, then now that my 3x has been multiplied by each term in that second binomial, I'm going to multiply my 2 by both terms. So my 2 has to multiply by my x, which is 2x. I'm going to put that in line with my 9x since they are like terms. And then my 2 has to multiply by my 3. So 2 times 3 is 6. Now I can go ahead and add like terms. 3x squared plus nothing is 3x squared. I have 9x plus 2x for a total of 11x plus 6. Let's do the same thing here for our next set of binomials. So I'm going to have 2r minus 7 times 5r plus 1. I'm going to go ahead and distribute this 2r. So I have 2r times 5r, which is 10r. And I have 2r times 1, which is just 2r. Sorry, 2r times 5r is 10r squared. Okay, let's go on to our next term. Remember to take the negative in front of your 7. So negative 7 times 5r is going to be negative 35r. And then negative 7 times 1 is negative 7. Now I'm going to go and I'm going to add together like terms. So as I distributed, I multiplied. And now I'm going to add like terms. So 10r squared plus nothing is 10r squared. 2r minus 35r is going to be negative 33r. And then I have just my negative 7 on the end. Okay, now that we have remembered multiplying binomials, we are going to do the same thing with a different set of binomials, okay? This special case is called a difference of squares. So first, I just want you to look at number 1, number 2, and number 3 and see what you notice about these sets of binomials, okay? So maybe even pause your video and see if you can come up with some sort of pattern in these binomials. If you paused it, what I notice is that my first term and my second term in each binomial is the same. So I have an n and an n as my first terms, and a 7 and a 7 as my last terms. In my next one, I have a 2x and a 2x, and a 4 and a 4, right? In my last one, I have a 3 and a y, and a 3 and a y. Also, I have noticed that in these two binomials, one binomial is addition and the other is subtraction, right? Same thing with the next one. One is addition and one is subtraction. So there's one of each operation, and then my first term and my second term in both binomials are the same. So that's how I'm going to recognize that this is a difference of squares. Otherwise, I am multiplying exactly as I would, and you'll start to see a pattern in our product, okay? So looking at number 1, n plus 7 times n minus 7, I'm going to do n times n, which is n squared. I'm going to do n times negative 7, which is negative 7n. Now I'm going to go on to my 7. 7 times n is 7n, and 7 times negative 7 is negative 49. Now when I add like terms, I have n squared plus nothing, which is n squared. have negative 7n plus 7n, which is 0, and then negative 49 on the end here. So my final answer is n squared minus 49. Okay, let's try the next one. I have 2x minus 4 and 2x plus 4. So I'm going to distribute my 2x. So 2x times 2x is 4x squared. 2x times 4 is going to be 8x. Now I'm going to distribute my negative 4 across that second binomial. So negative 4 times 2x is negative 8x. And negative 4 times positive 4 is negative 16. Now I can add together my like terms. 4x squared plus nothing is 4x squared. 8x minus 8x is going to be 0. And then I have negative 16. So my final answer is 4x squared minus 16. Okay, so let's pause here before we do our last one. I have noticed my difference of squares because each binomial has the same first and second term. One is addition and one is subtraction. Now, if I look for a pattern in my answer, I notice that both of them are subtraction, which makes sense because we call this a difference of squares. And remember, difference is subtraction. I also notice that I'm missing my middle term, right? I have a squared term, but I don't have a linear term. So I have n squared, but no n. I have x squared, but no x term. The way I found this term is really just by squaring my first term. So if my first term is n, and I square it, I get n squared. My second term is 7, and if I square it, I get 49. Okay? My first term in number 2 is 2x. Remember, when I square 2x, I have to square the 2 and square the x. 2 squared is 4, and x squared is x squared. So 4x squared is 2x all squared. Okay? My second term is 4, and 4 squared is 16. So really, I'm just squaring the first term and squaring the second term, and there's going to be subtraction in the middle. So with that said, look at number 3 and see if you can figure out exactly what that should end up as. If you still want to do the distribution or the foiling or the boxes, you can certainly do that to multiply them as well. Okay, I'm going to have 3 times 3, which is 9. 3 times y, which is going to be 3y. Now I'm on to my second term. Negative y times 3 is negative 3y. And negative y times positive y, a negative times a positive is always negative, and y times y is y squared. So when I add these up, 9 plus nothing is 9. 3y minus y is 0. And I have my negative y squared. So just like if I had squared my first term, I have 3 squared, which is 9. My second term is a y. Y squared is y squared, and there's always subtraction in the middle. Difference of squares. So take a look at these two examples and see if you can simplify, or what I mean is multiply for me, please. Then we have x squared minus 16. X 4 squared is 16, and there's subtraction in the middle. For this one, I know 2x squared, I have to square the 2, which is 4. I have to square the x, which is x squared. And if I'm going to square 3, I get 9. So I should always have subtraction in the middle, 4x squared minus 9. There is your first special case. Your second special case is just squaring binomials. Okay, so first, let's just take a look at squaring things that are not binomials. Okay, x squared is like x times x, right? That's what it means to square something. So if I was going to square 2xy, I really am looking at 2xy times 2xy. And we know how to go ahead and multiply those. right? We multiply things that are numbers by things that are numbers, so 2 times 2 is 4. I have x's and x's. Remember, when I'm multiplying, I add the exponents, so that's 4x squared, and then y times y is going to be y squared. So I have 4x squared y squared. Now, when I look at a binomial, and I know it's a binomial because there's two terms, right? There's this minus sign in the middle that separates my first term from my second term. This one up above didn't have any addition or subtraction. So 2xy was all one term. Okay, when I am multiplying something that has two terms, 2x minus 4 squared is like 2x minus 4 times 2x minus 4. We know that because that's what it means to square it, right? What you are going to be inclined to do is square 2x, which is 4x squared, and square negative 4, which is 16. Okay? Please, please, please do not do that. You cannot just square each piece when there are multiple terms. We have to remember that it's really 2x minus 4 times 2x minus 4. Okay? And if we are going to solve this, we are going to do so by distributing. So I'll take 2x times 2x, which will give me 4x squared, but then 2x times negative 4, which will give me negative 8x. Now I'm on to my negative 4. I have negative 4 times 2x, which is going to be negative 8x squared. Not squared, negative 8x, sorry. And negative 4 times negative 4, which is going to be a positive 16. Now when I combine like terms, I have these x terms in the middle that I can combine. So I have 4x squared. Negative 8x minus 8x is negative 16x. And then I have plus 16. So we can't just square the first term and square the second term, or we miss this whole middle linear term. Okay, let's try some more of these. We have 8x plus 3 squared. Instead of squaring my x and squaring my 3, I'm going to remember that this really means x plus 3 times x plus 3. Okay, x times x is x squared. X times 3 is 3x. Now I'm on to my second term. 3 times x is 3x, and 3 times 3 is 9. When I combine my x's, my like terms, I have x squared plus 6x plus 9. Okay, let's try it if we have a subtraction in there. So I have x minus 3 squared, which means x minus 3 times x minus 3. Okay, now I can distribute. X times x is going to be x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is a positive 9. Combining these like terms, I now have x squared minus 6x plus 9. Okay? So we can see that our pattern is this middle term is going to have the same sign as the sign in your binomial. The middle term is going to be adding this, and the outside term, the last term, is going to be multiplying. So 3 plus 3 is this 6, and 3 times 3 is this 9, right? Similarly, over on this side, there's subtraction, so I know this is going to be subtraction. Negative 3 plus negative 3 is negative 6, which is in the middle here. And negative 3 times negative 3 is going to be 9. Take a moment and see if you can solve these last two here, please. Now, finally, you have homework. Your homework is going to be 18.3 in your practice workbook. Or you can look at Z9 and Z10 in IXL. And that's under your Algebra 1 tab. So if you've already done the practice workbook, Z9 is your special cases, and Z10 is just